welcome back, and we are continuing with our study of trig identities, and we're hoping that you've tried some for yourselves. And let's dive straight in and have a look at these. If you haven't tried them, then pause the video rather and have a go. Okay, this is an interesting one. I'm not really too sure where to start, okay? But the worst thing we can do is to do nothing. If we write nothing, we're going to get no marks whatsoever. Okay, so one option here would just be to look at the left-hand side and change tan to sine over cos. And on the bottom, change the tan to sine over cos. Okay, now this is quite hectic because we've got like a double-decker fraction. I'm going to show you a little trick here to eliminate a double-decker fraction. If we multiply by cos x over cos x, now remember cos x over cos x is just 1. We're not changing the value, all right? Then watch what happens. This cos x needs to multiply with the 1, and we get cos x. And it also needs to multiply with the sine x over cos x, and it divides out. So we get cos x plus sine x on the top. And on the bottom, we get cos x minus sine x. Now that is much tidier. Okay, now, hard to know exactly what to do next. Let's go to the right-hand side and see what we can do. All right, now, the right-hand side looks like this. We've got 1 plus sine 2x. Now, sine 2x is actually 2 sine x cos x. And on the bottom of the right-hand side, we've got cos 2x. Now, remember there are 3 flavors for cos 2x. There's one that's got cos squared minus sine squared, and it's a difference of 2 squares. It's a difference of 2 squares. So if we go with that one, cos squared x minus sine squared x, are we okay that the bottom of the right-hand side can factorize to cos x minus sine x and cos x plus sine x? Okay, now that's good news. I'll tell you why that's good news. Because if we look at it, we want a cos x minus sine x on the bottom. So that's looking good. Now on the top, we need to have 2 cos x sine x's. Okay, cos x plus sine x, and we need to have it twice. Okay, so let's just write it down twice and see what happens here. If we write it down twice, cos x plus sine x. Once because we need it on the top, and once to divide out with the one on the bottom. Why is this now actually correct? Okay, because if we square out the top, we're going to get cos x times cos x, that's cos squared, remember that. We're going to get cos x times sine x twice, there it is, and then we're going to get a sine squared x. Guys, sine squared x plus cos squared x is 1. That 1 there is actually cos squared plus sine squared. Okay, and now this is good to go, because now we can divide out one of these cos x plus sine x's, and that now is equal to what we got before. So we've got therefore the left hand side equals the right hand side. Okay, just to emphasize what we actually did there, we thought of this one as a sine squared x plus a cos squared x. Okay, so that one, which I've written with green and highlighted in green, is actually the same as that stuff. Okay, quite a tricky one. All right, sine 3x. Sine 3x is interesting because we don't have a formula for sine of 3x, but we do have a formula for sine of something plus something. So 2x plus x. Okay, so this is the left-hand side. Now let's, maybe you want to try now pausing the video and trying to unpack this expansion, okay? All right, and keep going, keep trying to unpack it. But remember that if you've got a cos 2x think carefully about which of the flavors of cos 2x you're going to want to use. Look at the final answer here. Has it got any cos's in? No. So when you choose your cos 2x, choose one that's only got sines in it. Have a go. Okay, so here we go. Let's have a look. Sine 2x plus x is sine 2x cos x plus cos 2x sin x. Okay, now sine 2x we know is 2 sin x cos x. And then there's another cos x, so 2 sin x cos squared x. Cos 2x, and I mentioned this earlier, let's use the one that's only got sine squareds in. So in other words, let's use the one, I'm going to copy that sine x, I'm going to put it at the front of the bracket here. And here I'm going to go with 1 minus 2 sine squared x. Okay, now it's looking good, but we've still got cos squareds. How can we replace cos squareds? Cos squareds are the same as 1 minus sine squareds. Just to emphasize what we've done here, that yellow stuff became that yellow stuff. This cos squared x, we're going to replace that with a 1 minus sine squared x. So watch what we're going to get. We're going to get equals 2 sine x 1 minus sine squared x. Over here we're going to multiply this in, we're going to get a sine x, and we're going to get a minus 2 sine cubed x. Sine cubed x. Okay, now when we multiply that, so that green stuff there got replaced by that. Now if we look at what we've got here, everything's just got sines in it. Okay, and from here it's just algebra. When you multiply 2 sine x by 1, you get 2 sine x. Then we're going to get a minus 2 sine cubed x. We've got a plus sine x. And we've got another minus 2 sine cubed x. And those 2 sine cubed x's give us, the negative 2 sine cubed x's give us negative 4 sine cubed x. And here we've got 2 sine x and 1 sine x, we've got 3 sine x. So we've got 3 sine x minus 4 sine cubed x. Okay, and there it is. Okay, we shouldn't maybe underline that just yet, because we should be saying equals right hand side. Okay, and guys, it's very exciting when one gets one of these right, especially if one's got one right on one's own. Okay, and the only way you're going to get that is with loads of practice. Learn the identities and do loads of practice. Okay, I think this might be it's not quite the last one, but it's the last one of these types. Let's take a look at this one. Let's look at it together. Now, we've got 5 and 15 and 10 and 5. I don't know how to do this question. I've not done it before, all right? But I'm guessing maybe, and we might be wrong here, but I'm guessing maybe we want to break this into 5x plus 10x. So in other words, cos 5x minus cos of 5x plus 10x. And let's see we're just trying. We're just seeing what we could do here. So this is the left hand side. Right, I'm going to leave the cos 5x as it is. And over here, we're going to put in the expansion for cos 5x. Okay, cos 5x plus 10x. That's going to be cos 5x cos 10x. Then it's going to be minus sine 5x sine 10x. Okay, so what we're going to end up with here is cos 5x minus cos 5x cos 10x minus sine 5x sine 10x. Okay, this minus is actually going to be minus minus, so it's going to be a plus. All right, now it's looking a little bit terrifying, okay, but cos 5x minus cos 5x cos 10x, all right, we could maybe, yeah, let's see what we might be able to do here. Okay, it's looking a bit intimidating, I would agree, but let's maybe change. See, I'm liking this sine 10x and I'm also liking this sine 5x, so maybe let's change okay, maybe let's change cos 10x into 2 cos squared 5x minus 1. We've still got sine 5x and sine 10x. Okay, now this is going to go to cos 5x minus 2 cos cubed 5x plus cos 5x. This is actually going to go, if we take out a cos 5x, it's going to go to 1 minus 2 cos squared 5x. All right? Yeah. Okay. Plus another cos 5x. And we've still got these bits that I haven't written down there. Okay, guys, we're getting jammed, all right? It's not, I'm not feeling all that confident about this, okay? I don't know where it's going, okay? I am going to just try one last thing. If we took out a cos 5x now from these terms, we would get 1 minus 2 cos squared x, cos squared 5x plus 1. All right, and then we would get cos 5x 2 minus 2 cos squared 5x. Okay, it's not looking good. Okay, all right, I'm going to suggest we go back to the drawing board, and I know you're going to think, wow. Okay, all right, and we're going to try this time from the right hand side. Okay, so we're going to have another go at this one. Okay, one's got to be very careful in an exam that you don't spend an hour trying to do one of these questions, because yeah, you might be thinking, sure, if Paul can't do this, how are we going to do it? Okay, but all of us actually kind of get stuck from time to time. Okay, let's have a look at the right hand side. Okay, and the right hand side is actually, if we change that to 2 sine 2 lots of 5x times the sine of 5x. Okay, and now we're going to use our double angle formula for sine. So in other words, the sine 2 5x, that's going to be 2 sine 5x cos 5x. Right, times the other sine 5x. So in other words, what the right hand side actually comes to is 4 sine squared 5x cos 5x. Okay, that's only got one term, So let's change the sine squared 5x to 1 minus cos squared 5x. And here we've got cos of 5x. So now what we've got is we've got 4 cos 5x, which is going to multiply in here. So we're going to get 4 cos 5x minus 4 cos cubed 5x. Okay, and we try to see if we could get it to look like this one over here. All right, so on the left hand side, let's just try again. We've got cos 5x minus cos 15x. Okay, I'm going to try again, and I can't remember exactly what I tried last time, but I'm going to try cos of 10x minus 5x and minus cos of 10x plus 5x. Okay, and so this becomes cos 10x cos 5x plus sin 10x sin 5x, and this one becomes minus, and now we're going to get a minus inside here, so we're going to get minus cos 10x cos 5x okay, and then this is going to be minus, so it'll become a plus sin 10x sin 5x. Okay, and in fact, I think we've actually got there the other way around. Okay, so and I'll explain what I mean by that. So this screen stuff I don't think we're going to need, because notice that this cos 10x cos 5x actually subtracts there, and now we've got sin 10x 5x sin 5x, and another one we've got 2 sin 10x sin 5x, and that, guys, is actually equal to the right hand side. Okay, let's just have a look. Yeah, that's equal to the right hand side. So notice that I did a whole lot of fiddling around here and it didn't work, and then when I tried this, it worked. Okay, so don't get caught up on these questions spending hours, because they can go wrong, as we've demonstrated. Okay, right, before the next lesson, try these next questions. They all involve double angle and compound angle stuff, all right, and then we're going to look at some equations as well. Try as many of these questions as you can. We'll talk about them next time. Thank you.